Good evening, everyone, and thanks a lot for joining us. We'll wait for another 2 minutes for the others to join, and then we'll start. Okay, I think it's time for us to start. Once again, a very good evening. I'm Sanat Sogani, part of Plaksha's admissions and outreach team. I'm aware that some of you here have probably attended our events before. There are others who would have heard of Plaksha only recently. We have educators from all around India, parents, students, and of course, members of the Plaksha community. Again, a very warm welcome to all of you, and thank you for your continuing support to Plaksha. With us, we have two very, very special guests today. First is Dr. Dhiraj Sinha, who is the director of and the founder of the Collaborative Robotics Lab at Purdue. He's also a curriculum advisor to Plaksha and has had a very important role to play in shaping up what has come to be known as Robotics and Cyber-Physical Systems. Thank you, Richard, for your time. I'm aware this is early morning for you.
Happy to be here. Thank you.
Thank you. And we have with us Dr. Dhiraj Sinha. Some of you may have met him in your admissions interviews or at other events. Dhiraj is one of our founding faculty members. He has an extremely important role to play in setting up the pedagogy at Plaksha. He holds a Ph.D. In electrical engineering from the University of Cambridge, and he's also been a postdoctoral research fellow at MIT. Thank you again, Dhiraj, for joining.
Thanks, Sanat.
So what we're going to do today is, for those of you who have only come to know about Plaksha recently, I'll give you a 5-minute overview of what Plaksha, the upcoming Plaksha University is all about. Then we'll hear for about 20 to 25 minutes about robotics and cyber-physical systems more generally, as well as what it means at Plaksha from both Dr. Sinha and Dr. Voyles. And then we'll move into Q&A for the last 20-25 minutes. As most of you would know, there is a Q&A option in Zoom. Please post all your questions there, and I'll try taking all of them towards the end and avoid using the chat box. So let me straight get into the presentation now. So Plaksha is an upcoming university in Mohali, which is in Punjab near Chandigarh. As I've already introduced, we have two guests with us who will be talking about the Robotics and Cyber-Physical Systems program at Plaksha, both of whom have specializations in the field as well as have played an important role in setting up the major. What's unique to Plaksha is our differentiated engineering curriculum. Our vision really is to reimagine technology education for India. How are we reimagining it? First, by saying, let's break free of the silos wherein a student is just expected to choose a stream in 11th grade, and then after 12th, they're expected to choose, let's say, between medicine and engineering. And then if they choose engineering, then it's a very specialized degree in, let's say, electrical or mechanical, etc. So instead, what we are doing is we are bringing together 2 or 3 different branches of engineering and beyond, which are very important to solve problems of today. Second, our learning is extremely hands-on, something that both Dhiraj and Richard will talk about. And third, we want to go beyond just making engineering degree a ticket to a particular job. Both Dhiraj and Richard will give you an overview of what kind of careers to expect after robotics. But what you will also realize is it's not just about you study something for 4 years and you get a guaranteed job in something. The goal is something broader than that, and that's something we'll talk about today. Another important thing about Plaksha is that the university's overall function is very transparent and democratic. The university is not owned by any single individual or corporate group. There are almost 75 founders now who are involved. These are business leaders, philanthropists, technological entrepreneurs, includes people like founders of Genpact, of Zomato, chairman of BCG Asia, etc. Alongside that, we have a stellar academic advisory board. As I'm sure you would have seen from both Dr. Sinha and Dr. Voyles' credentials, we are attracting some of the best faculty talent from around the world. Some of these faces you might be familiar with, Dr. Abhijit Banerjee, who won the Nobel Prize in Economics, Dr. Arvind Raman, who is the Senior Associate Dean at Purdue, Dr. Kaushik Basu, who's been the Chief Economist at the World Bank. So again, these are not just faces. These are people who are very committed to the project and are laying down the overall foundations of the university. Finally, our overall outlook to education is extremely international to the core. We also have 3 partnerships in place already. University of Berkeley and University of Purdue are our academic partners. That is, there's a lot of faculty as well as student exchange happening between these 2 institutions already, but also these 2 institutions are heavily involved in building the curriculum. And this is something that Dr. Voyles will also talk about. So I think this is a good point to just pass it on to Richard to take over.
All right. Thank you. Let me start my slides, and I am going to share my screen here. Pardon me. All right. Okay. So again, welcome to this open house, and appreciate your time. I'm going to talk about a little bit about what we're referring to as Robotics 2.0. And what that means is kind of a new way of looking at robotics. But first, let me explain a little bit about who I am and where I came from, and how I got into robotics. First of all, I got my bachelor's in electrical engineering from right here at Purdue. I went on to get a master's in mechanical engineering out at Stanford. And then I went on to get my Ph.D. at Carnegie Mellon in the Robotics Institute. And I was actually one of the first inaugural class of Ph.D. students in robotics at CMU. And even my work at Stanford, when I went there as a student, I was one of the first in a group in mechanical engineering and manufacturing engineering. And so I think this is really an exciting time for Plaksha to be part of this new way of looking at robotics curricula. I went on to interspersed with my my educational career. I worked at big companies like IBM and small companies like Integrated Systems and Dart Controls. I started some companies and even worked in government and as well through our National Science Foundation in the US. I worked at the White House for a while on robotics and CPS, Cyber-Physical Systems policy, and also at the Department of Energy. And so this is, I think, that mix. Robotics represents that mix of electrical engineering, mechanical engineering, computer science that is really exciting and opens a lot of doors. But let me talk a little bit about what we mean by Robotics 2.0. what we've been calling this, and really internationally, is this is a new era in cooperative robots. And here are some examples here of, you can imagine, robotic and human space explorers, right? Working cooperatively and in fact, symbiotically together. It's about sensors and mechanisms, and this picture over here on the right, it's really about a lot more about human and robot interaction, right? How robots can work with humans to get the job done. And if we're talking about robotics 1 or 2.0, we should also explain, well, what was robotics 1.0? And robotics 1.0 was considered the era of lights out factories. And that's an example here of these big robots that are assembling automotive final assembly. And you can see these are robots, they're sparks flying, they're doing dull, dirty, and dangerous jobs. And in fact, the robots also are dull, dirty, and dangerous. And if you look, you don't see any humans, right? Because the humans are actually locked out by these fences. They're walled away from the robots because the robots are just too dangerous. And in fact, if you look in this green area, there are some humans, but very few humans out here in the safe zone. They're just for maintenance. And that's why we call it a lights out factory. And here's the danger zone. This is where all the robots are. But again, this was an era of trying to replace human workers with what was supposed to be more efficient robotic workers. But that just didn't always happen. And so with robotics 2.0, it's much different in that we're trying to combine the mechanical engineering, the electrical engineering, the computer science, and the human science, right? To actually make robots that work cooperatively with humans, that leverage the strengths of natural intelligence using artificial intelligence, and advanced mechanisms, right? So they can actually work side by side. And that's what Plaksha is trying to do in terms of this new curriculum. And so I think it's a really exciting time. Now you might ask, if you've watched the outlay of new products, whenever there's a 1.0, there's always a 0.1. And so you might ask, well, what was robotics 0.1? And robotics 0.1 was really kind of the fantasy world that Hollywood and Bollywood and various movie and media outlets kind of created this view of what robotics, what they wanted robotics to be. And unfortunately, that drives a lot of people's expectations of what robots can do. And many of these, of course, we look at all these examples and they're either generated by computer animation, right? Or in the old case, even hand-drawn automation, or human actors, right? C-3PO in Star Wars being a classic example. Even R2-D2 was operated by a human inside. And that's the study that we're trying to achieve at Plaksha, and what the work we're doing at Purdue and kind of all over the world is capturing how to make those robots more amenable to humans. And if you look at these examples, these in fact are all from our science fiction movies, and are all robots that actually work with humans. They help humans, not replace them. And so that's what we're trying to achieve with the curriculum that we're developing in robotics. And cyber-physical systems is just the networked version, where cyber refers to the computer parts and the computational parts of CPS, and the physical refers to the fact that it's about computers interacting with the physical world. But what we're doing in this, and I'll give you just a quick overview, and this is actually kind of a combination of what's evolving at Purdue's robotics program, and what we're infusing into Plaksha's program is this combination of basic science using math, basic electronics, basic mechanical work, but also with a social element. It has elements in psychology and sociology and Indian civilization, but also builds on math and physics to look at the elements of robotics in a way that it can hit this grand challenge studio of really addressing meaningful problems. And let me give you some examples, right? And here are some earthquake in the field of search and rescue robotics. Here are some examples from all over the world of what it actually looks like for human emergency workers to try to help and search for survivors in these kind of horrific incidents, right, of de-engineered environments. These are very complex for humans to work in, and even dogs are often used to help find people. And so it's really difficult to create a robot to do this, not only to navigate over different terrain, difficult terrain, but to understand the, let me go ahead and start these videos, to understand the environment that they're working through. And so here are just a couple examples that we've been working on at Purdue. This is a very small robot called Terminator Bot. It's a mechanism that can crawl through small areas of rubble. And the one on the right is something we call Mothership, which is for moving over this difficult rubble. And there are some other areas in, and I'm just going to show a brief portion of this video, that we're looking at beyond just the normal fabrication approaches for robotics, but this is an example of a origami printed robot with some motors attached to it. Again, but we're developing these things in the lab and actually use them with some of our undergraduate classes. And so there's a lot of real excitement that we can bring in robotics. Agriculture is a big application area for robotics, is another one. And in this case, right, it's really about getting sensor information and understanding crops from aerial views, from local sensing information, and networking all that information together, connecting data science to the electrical, mechanical, and computer engineering. And again, packaging it for human consumption. That's the human science part. So that's what I have in terms of my introduction to myself and what robotics and cyber-physical systems is. And I'll turn it over to Dhiraj.
Thanks, Richard. Sanat, can you share your slides?
Now I'll share the slides for you, Dhiraj. There you go.
So Richard has already provided an amazing overview of the field of robotics. Sanat, just can you hear me well?
Yes, I can. Yes, I can. Yeah.
So at Plaksha, we have got 4 programs. So the previous slide, please. So yes, we have got 4 key programs: computer science and artificial intelligence, robotics and cyber-physical systems, biological systems engineering, and data science, business, and economics. In fact, all these are our 4 core verticals, and there is close synergy between all these subjects. And robotics tends to run through all these disciplines in some way. Okay, and so as you advance through this undergraduate program, you'll be introduced to different aspects, and the objective is to offer a holistic training in different fields and subfields. Okay, next slide. So this defines actually our operational philosophy on project-based learning, which should span across the 4-year curriculum. In fact, in general, what happens is that engineering education in India still is very much focused on concepts and phenomena. Okay, So people are taught a lot of things, and they are taught in very intense manner, and then they are asked to solve numerical problems, and there's very little focus on addressing real challenges for the industry. And at Plaksha, we really want to change that while partnering with our collaborators in USA and other countries. So an important focus is building products in maker space. So students should be exposed to real world challenges where they'll be able to make and create real artifacts. The other objective is designing research ability. In fact, there is difference between education and research. For educational training, in educational training, we focus on what is known. In research, we explore what is unknown. So an important objective of Plaksha is to train students so that they are able to solve problems which have not been solved. Okay. The other thing is mentoring and professional development. So we'll have a team of researchers, faculty members will guide. An important thing is social responsibility and awareness. In fact, engineering education without understanding the context of society is absolutely useless. India has got specific problems. In fact, we have to manage traffic, we have to address the problem of sanitation, healthcare, agriculture. So our program is designed to touch these problems in a very strong manner. Okay. And we'll have multi-year projects with industry and community which is aligned along innovation and entrepreneurial mindset. Okay. So we expect the students to come up with new solutions to problems so that they are able to create new institutions which have a certain level of impact. In fact, this is again a challenge of Indian engineering education where we train students who just want to get good jobs. In fact, while this is an important thing, we also want students who are interested in building new institutions, new companies, new laboratories, and new artifacts around their visions and missions. And so we want to create a framework which allows students to achieve those goals. Next slide. So addressing the core challenge of engineering education is one of our key missions, in fact. An important goal of Plaksha is to address the challenge between theory and practice in engineering education. In fact, we plan to achieve it by allowing the students to get fully immersed in technology during the course. In fact, currently in engineering schools, the students are taught some basic concepts and then they're asked to solve numerical problems. And then they develop their quantitative aptitude. Our approach is going to be quite different. We will start from concepts and move to devices and then to industrial problems and teach you how to solve those challenges while developing physical as well as numerical insights. So, for example, when we teach students the principles of electrostatics like Coulomb's law and all sorts of things, we will ask them to make prototype of a photocopier, for example, by using principles of electrostatics to create words and images on plain piece of paper, the way a real photocopier works. Similarly, when we teach amplifiers, which are used in all sorts of devices to increase the amplitude of signals, we will expect students to come up with real audio amplifier designs, which produces very high quality sound and is in some way comparable to industrial grade amplifiers. And in the process, we will expect students to develop some kind of insights about how actual devices work. So the overall goal is to develop a holistic skill set comprising of hardware, software, while implementing the problems in an industrial context. So next slide. So yes, so we plan to have, we are very much working towards developing unique labs for undergraduate education. Normally, advanced laboratories are actually meant for research because equipment usually are very costly. So students at bachelor's level are allowed to give a visit, but they're really not allowed to do much work. I was at MIT where they have a very different culture and they do allow students to work on some specific projects. But again, things are very much limited. A lot of work of undergraduate education is done on specific labs. We want to change that. Our approach is from that perspective, it's very unique in that sense that all our labs are actually aligned towards educating and training young minds, where you will learn new things and will be able to explore and test new ideas against the wider context of society and industry. So at this stage, in fact, we are working hard towards building a lab on robotics with a specific maker space. We'll also have a separate lab on electromechanical devices with related computational facilities. So we expect to have a basic setup where students would be able to transform their creative ideas into specific prototypes, which solve real engineering problems. Okay, next. So as we mentioned, in fact, we have discussed this thing in the past, like the focus is on experiential learning, like learning by doing. So we will, the focus of teaching would be on projects which have strong industrial relevance. For example, we'll make you work on futuristic ideas like flying taxis. Of course, it's a huge challenge as the problem remains unsolved. We'll break it down into different modules and sub-modules. And by the time you graduate, you'll be at least able to see a working model. Now, we do not expect it to carry you to your hometown, but we should hit flying in our fields and our backyard. Now, there are other ideas which we plan to work on, for example, house making using 3D printing technology. So you will have the freedom to develop and design a printer and assemble its components and parts. So we are basically deviating from current way of teaching students by using existing devices. The focus is to train students so that they're able to make new devices. And micro robotics is also going to be our core focus. For example, robots with the size in the range of millimeters to a couple of centimeters. For example, you will have a chance to work on projects like making a micro robot which could crawl through different kinds of complex structures. Richard explained one such robot which could be used for rescue operations. Similarly, you will also get a chance to work on other interesting ideas like drones for agriculture, driverless vehicles, and automation for construction, and so on. So, next slide. So yes, so these are again some of these challenges related to robotics on which a lot of people are working. In fact, many of you could argue that perhaps we don't really need many of these devices because they will destroy jobs. But this is not true. In fact, robots basically are designed to augment our productivity, and India has got so many challenges which could be really solved by these kind of things, and a coherent integration between robotics and cyber-physical systems. Next slide. So these are our indicative list of courses. So in fact, of course, students should be trained in basic aspects like engineering, mathematics, and physics and other aspects. But in fact, robotics, dynamic systems, robotic control, embedded systems. And then students will also get a chance to opt for elective courses, like some advanced courses like solve robotics, computer vision, micro robotics, autonomous manufacturing, and so on. So the idea is to create an engineer who understands the finer aspects of different industry verticals. Okay, next slide. So this is a question which students usually ask. In fact, why should we study? What are we going to get out of it? In fact, because if you pick up a general newspaper, you won't find many advertisements for robotics engineer. Okay, so this is a question which particularly parents have, that what's going to be the outcome of this course. In fact, 20 years back, in fact, there are very few advertisements in the field of software engineering because India was slowly opening up to software engineering. Okay, a lot of appointments were through campus placements in IITs and some other universities. And robotics basically stands at the same level which software industry was 20 years back. So things are slowly changing. So this is a very hidden and latent demand, and it will keep on increasing linearly, and I would even say exponentially. So the core, students will get a chance to work in core sectors as robotics engineer, automation engineer, or embedded systems engineer, And there are a lot of companies operating in this segment. We've got ABB, Siemens, Honda, and others. And there are a lot of small companies which are again making entry into this domain. Of course, you will have the option of working in conventional companies, like for example, automobile engineer, while working in companies like Ford, GM, Toyota. So robotics is a field which basically touches almost all the aspects of engineering. Like you will be trained in fluid dynamics, you will be trained in concepts from mechanical engineering, electrical machines. So it won't close your doors. Like it opens new doors. Okay. Similarly, in fact, many students may think that perhaps it will close the doors to IT and other roles, and this is a very wrong perception, because in the field of software engineering, a lot of projects are for different industrial verticals. For example, software engineers can work on projects related to automobile engineering, or you could be working on programs for Boeing, aerospace, agriculture, and so on. So at Plaksha, we plan to expose the students to challenge the different fields. So we will always have this option of moving to software, finance, consulting. And then, in fact, we also expect a certain number of students to explore entrepreneurship option. You will have the option to start new companies or join some
Dhiraj, I think we're losing you. Richard, Kanchi, can you confirm if it's me or if it's Dhiraj's net?
Yeah, I've lost him. He's broken.
Yeah, it's still breaking. Let's just wait for a minute.
Yeah, it's Dhiraj's internet, I think, not ours.
Got it. So while he joins back, Richard, did you have anything to say on this slide?
Yeah, I think as Dhiraj was saying, there are really a lot of pathways that can go, and one of the things we've learned in the United States with FIRST Robotics, which has actually grown into this international opportunity for high school kids to get engaged in robotics, is they don't all go into robotics engineering. Many of them branch off into many areas of STEM fields, and that's what's exciting, and why I was pointing out, it's really a connection of many disciplines. I studied electrical engineering, mechanical engineering, computer science, and then human science, right? Now I'm looking at animal science. And so, there are just many, many things you can do when you have been trained in these basic robotics and cyber-physical systems disciplines. So yeah, I think and you look at this list of companies in terms of how you can, and not just companies, but nonprofit organizations and government entities. And I think, my career is an example of that, where I've worked in government, I've worked in industry, I've worked in academia, in many different departments. So I've been a professor in a computer science department. I've been in electrical and computer engineering department. I've been in robotics. And so again, this is really a holistic type of education, which I think is really valuable.
Okay, thank you so much. Since we are at the half-hour mark anyway, I thought we'd move into Q&A. We have some questions already, but before I take those, I'll ask my question first, because I have that privilege. So the question that I have, Richard, is this term cyber-physical systems. I mean, we use it all the time, but as I mentioned, I don't think I am entirely clear of what that means. Could you unpack the meaning for us?
Sure. It is. It's a complex term that arose out of the academic community, and we really wrestled a lot in my role, both as a professor and as a government policymaker, of how's the right way to communicate this to the general public. And the Internet of Things was kind of, the Internet of Things and cyber physical systems are really kind of different names and slightly different aspects, but they're heavily overlapping. It's the idea of using networked communications, tying it in with physical activities of daily life, whether that be at work, like in manufacturing or business, or at home in terms of healthcare, or just daily conveniences of, getting coffee in the morning. But the cyber and the physical refers to just like the Internet of Things, it's the connection of computers and computation with the physical world.
Okay, thank you. That I think answers my question. The other one is from a student who is actually wanting to do the computer science and artificial intelligence program at Plaksha, but he asks if, let's say, he'll be able to take a couple of modules in robotics because he feels that's important to solve some of the problems that he's passionate about.
Yes, indeed. The programs are designed first off to start off so that all students start together with common classes, and to build a cohort across these disciplines, because you're exactly right. They're all highly interactive. And we do want to share many of the class modules, and there is flexibility. Of course, there is specialization, but as the schedule allows, yes, we really want this, and this is what we feel is valuable. It's this mixing of disciplines, even though the disciplines Plaksha has chosen are highly interdisciplinary to begin with. We still want that feel that as students specialize in AI, or they specialize in biology, or they specialize in robotics, they're going to feel connected to other students in the cohort.
Okay, thank you. And we have a connected question to that. So suppose a student does not take any modules in robotics, but do you think as someone who has done the CS and AI program, can he still expect to, let's say, write the software as far as robots are concerned, or is that quite a different field?
That's an excellent question. My first question is, why would you not want to take a class in robotics? but that's my view, and I understand, right? Yes, I think each of these disciplines, again, they have their specialties, but we are with the Plaksha curriculum, and that's what's really unique about it, is these divisions loosely follow the traditional silos that students are familiar with, but the intent is to break down those silos and to really have an interdisciplinary program. And so the answer is yes, right? If you're focused on the AI, and I believe, even as an electrical and mechanical engineer, right, I really think that software and software development, particularly AI technologies and machine learning, right, they're dominating kind of all aspects of STEM fields, of engineering and science. Physicists are increasingly focused on data and data science, right? And electrical engineers, mechanical engineers, these mechanisms and devices, again, they're increasingly being dominated by programming and artificial intelligence. So yes, I think robotics, the Robotics and CPS program, as distinct from the AI and computer programs, it's just a shift in we're focused a little bit more on the physical and how to do mechanism design, how to do basic electronics. But yes, there's a lot of opportunities for interchange between the fields. And again, as you go off into your various careers, the goal is to promote lifelong learning. And what we're increasingly referring to is lifelong teaching. We actually, because you learn most from being able to teach something. And as STEM trained practitioners, right, that's part of your job in life, is to explain science to people.
Okay, thank you. Dhiraj, are you back? Okay, I think we lost him again. In that case, I'll just move on to my next question. So this is about, as you mentioned, part of our curriculum will actually cover some of the traditional courses that are taught in, let's say, electrical engineering or mechanical engineering programs. So do you think there will be something different at Plaksha in how these courses are taught?
Yes, I think so. And you know, things are evolving, of course, and that's what's exciting about this is, you know, I mentioned when I was a student at Stanford and Carnegie Mellon, I had the great opportunity as one of these entry-level students to actually help shape the curriculum. But that's what we're trying as advisors, and Purdue and Berkeley and SRI, you know, we're trying to help the Plaksha team to really understand, right, that this is not the real opportunity, we think, for the future is to really have a different, more holistic view of what it means to be a STEM engineer or a scientist in the world of the 2020s and beyond.
Okay, thank you. I'm sorry you have to take all the questions, but these are all very exciting, so I'll just shoot them one after the other.
That's all right. We'll find Dhiraj at some point here.
The next question is a very interesting one. I think I've personally had that question. You know, as a school student, I barely had access to facilities, which would allow me to, you know, firsthand experience what robotics means, although I went to a reasonably good school. But that's not true, let's say, for computer science, because that's something that most students end up trying anyway, at least in India. So do you have any suggestions on how students could get an insight into this major before they decide whether they want to major in this field or not?
Ooh, that's a good question. And yeah, I think, you know, you know, first off, the internet has made so much available to all of us, right? In terms of MOOCs, these massive online classes, and you know, that are available free of charge, and going on to websites like my own website, like you know, MIT website. There are the IEEE has a wonderful site on robotics that looks at some of the various you know, from all over the world. And I should point out the IEEE is the International Electrical and Electronics Engineers organization. Again, it's an international organization of engineers throughout the world who maintains you know, educational programs and things like that. In the United States, NASA's site is wonderful because, of course, you know, there's just a new NASA rover, of course, that is landed on Mars again, and so there'll be a lot of videos and opportunities to interact with that program, just since it's very new at this point. You know, so yes, there are lots of ways to get the kind of glitz and glamour of what these fields could represent, but also, you know, many, you know, the universities around in India and in the United States, again through remote interaction, you know, offer you know, many opportunities for camps and programs, right, to kind of learn the hands-on aspects, the nuts and bolts of all these disciplines, right, computer science, robotics, electrical and mechanical engineering, to take advantage of.
Okay, thank you. And welcome back, Dhiraj. While you were away, I was bombarding you with some questions. I do have another one, and it's partly coming from me, but it's connected to a previous question, which is, you know, how do students get interested in robotics? Because if we talk about something like AI, I think nowadays it's pretty easy for me to see applications of AI. I just have to look at Alexa or Siri or similar things. But with robotics, it seems like, because all the applications that you mentioned were either, let's say, industrial or agriculture, in settings that are sort of distant from me. So do you think that's how robotics is going to be always, or do you think robotics is something that is also have a place in our homes and something that would be readily available to a layperson?
Well, yes, I think my view is robotics really came from, interestingly, it grew out of science fiction, but if we think of when the word robot originated, was way back 100 years ago, almost this year, in a play. And so it was entertainment first. But if we go back historically, even in ancient times, Aristotle wrote on, while he didn't use the word robot, right, talked about, basically, how humans, both mechanically, their physical labor, but also their intellectual labor could be, captured in some sense. And so this is what I find is really exciting about robotics is, and it's, humans have been thinking about this for millennia, literally, of the fascination of how do humans think? How can we capture and try to emulate that human thinking? And because we are so enmeshed with our physical environment in terms of our upbringing, even from infancy, that connection to the physical world is what really makes robotics, I think, has always been in the imagination of humans all around the world. So yes, anything that you have an interest in, right, potentially, that involves humans and how they interact with their physical world, whether it be something as simple as loading the dishwasher or washing dishes in the sink, to affecting climate change on Earth. I think there is an aspect of robotics and cyber-physical systems, the networked environment that could be global, that captures, has bearing on in those imaginations of your own, right? Students, has bearing on what you can learn and what you can build a career around.
Thank you. Dhiraj, do you want to add anything to that?
Yes, so robotic-based applications are slowly finding their ways in our homes and offices. For example, we have got automatic robotic cleaners, and a lot of companies are installing devices, robotic devices to clean windows and other things. And we expect to have robotic-based systems which would automatically prepare food for you. So a lot of companies are working on that. There is a Singaporean company which is working on an automatic roti maker. Okay, so this is really a typical Indian food, which is very challenging to make and consumes around 50% of cooking time. And so they are coming out of it. So, but certainly, in fact, progress along this direction has been slightly slow because of the fact that in the initial phase, costs are really high. And so you won't expect an individual to pay $100,000 for a device which could cook food and things like that. And so, but slowly, in fact, as the cost of technology is going down in the context of making robots, in fact, we'll find more and more applications of robots at homes and offices.
Thank you. I think, Dhiraj, just picking on your last point, a question that has come up is, do you think there is much scope for robotics in India? Considering the financial constraints, considering the kind of problems that we have, is robotics really an important technology?
So, in fact, let me state your question in a different framework. The question which you are asking is, do we have the need for software engineers? Do we have the need for people who understand hardware and software? Do we have the need for electrical engineers who also understand how mechanical systems operate? Do we have the need for engineers to understand the basic of fluid dynamics, thermodynamics, and software? The answer is certainly yes. We do need engineers who are skilled in different domains and who are adept at solving industrial problems. In fact, so the answer to all these questions is yes. So the answer to this question is also a big yes. The only thing is that the role of a robotics engineer is slightly hidden. Okay, so it's hidden from public view. On a day-to-day basis, you'd meet software engineers. You may have met electrical engineers, mechanical engineers, But in fact, that on their day-to-day life, and people who are working on these oil rigs, or people who are working in the telecom industry and other industries, they also have these latent needs for robotics engineers. But currently what they do is that they try to outsource it to some vendors and sub-vendors. But this, the sector is gaining momentum. And in fact, slowly, in the years to come, you will certainly find, you will be able to personally meet a lot of people who are really working as robotics engineers. So currently, in fact, this role and responsibility is very much, it has been subsumed and submerged by different domains and subdomains. It is yet to find a new identity, and that's one goal of Plaksha. Our goal is to give a specific identity to this field. An engineer who is designing a new kind of washing machine, which is a bit automatic and works in an automatic fashion, which is able to flow control, identify dirt. Essentially, he's also basically making some kind of robotic device. Okay, so certainly there is a lot of need in almost all the sectors, from government to private to all sorts of sectors.
Thank you, Dr. Voyles. Do you have anything to add?
I think Dhiraj said it exactly right, is don't think about just what robotics products, right? When you're talking about career impact, because, like I said, with, the vast majority of students that generate from robotics programs do not actually go into a robotics company. Right, it's those interdisciplinary skills of having a view of what happens in the physical world and how to control it has really implications on all companies.
Thank you. A recurring question that we're getting is on the prerequisites for the robotics and cyber-physical systems. I must clarify that in order to apply to Plaksha, math is a basic requirement. You need to have studied mathematics in grade 11 and 12. And if you are opting for our first three majors, which is computer science and AI, robotics and cyber-physical systems, and biological systems engineering, you also need to have studied physics. Now, there's another connected question to this, which I can't answer, which is someone, let's say, is not very interested in mechanical engineering, but they still are fascinated by robotics. Would you advise them to delve into this field?
I think Professor Voyles should start the answer.
You want me to start that one? Well, I think that again, when I look at the actual science, I mean, I'm biased. I have always been captivated by the idea of robots. I was drawn into robotics very early on with the 3 Mile Island incident, which happened even before I went to my BS program, and the opportunity back then, of course, that was a nuclear incident where there was an accident in a nuclear plant in the United States that, didn't release. There was a slight amount of radiation leak, but it wasn't a bad accident like Chernobyl or anything like that. But still, it was clear that the potential for robotics, because people just didn't know much about what was going on inside that plant at the time. And because, it was too dangerous to put humans in. And so it's those kind of things that started me thinking and about, what could robots do in a case like that? And it's kind of ironic that I didn't know it at the time, but I went later, many years later, 10 years later, I went to Carnegie Mellon and found out that Carnegie Mellon had actually sent a robot into 3 Mile Island, very much as I had kind of envisioned it as this high school and undergraduate student. And so again, I think I'm kind of biased, right? I think there are lots of applications for people in robotics, but again, it's the broad programs that we're trying to create here at Plaksha, I think, are designed to try to find what you gravitate to as a student. and still get an interdisciplinary experience that covers a variety of topics that bring things together and really enable what we're calling the Grand Challenge Studio. And let that expand into your career, right? And take that idea of interdisciplinary problem solving into your career is going to be hugely valuable in my estimation.
I just wanted to add a couple of points here, Sanath. In India, quite often, students tend to have a very narrow understanding of engineering. For example, they think that, well, software engineering is just about programming, electrical engineering is just about running motors and generators, mechanical engineering is about turbines and so on. Or maybe they think that chemical engineering is about some chemical reactions and so on. So the fact is that the role of an engineer is to solve problems, okay? Whether the problem could be related to creating a pacemaker to control, cardiological processes. It could be, a problem related to sending, man to moon or to Mars and so on. So basically, a problem is a problem and has got certain mechanical elements, software elements, mathematics, physics, and all sorts of things. I remember there was a student who said that, well, I love mathematics, but I hate physics. And that was very strange because a lot of mathematics has evolved from physics. So it's very difficult to love mathematics and hate physics, or love physics and hate mathematics, and so on. So similarly, it's almost impossible to love robotics and hate mechanical engineering, or love electronics and hate mechanics, and so on. So maybe sometimes young students have that kind of feeling, but once they are exposed to problems, they tend to develop a very big love for different elements and sub-elements, in fact. So engineering is engineering. It has got so many domains and sub-domains, from electrical to mechanical to so many things.
And let me just add along those lines, if I can just inject one quick thing.
Go ahead.
My PhD, again, this wasn't my bachelor's, but my PhD was actually in robotics. And when I went to interview for academic jobs, I commonly got the question of, well, what really is robotics about? What does this mean? Are you an electrical engineer? Are you a mechanical engineer? Are you a computer scientist, right? And the beauty was, while that added some uncertainty in the job market, it gave me the very confident ability to say, yes, I am, right? I mean, whatever, because I was interested in mechanical engineering. I was interested in electrical engineering. I was interested in computer science, and I could talk to any one of those potential employers and say, yes, here's how I fit into your organization. And in fact, I got 3 distinct offers, across the board from mechanical, electrical, and computer science, right? And that is, so it's a bit of a hindrance in some sense. Whenever something new is happening, people don't know how to interpret it. But at the same time, it opens doors because people are curious. And that's what we've chosen names in the Plaksha program to do a little of both, to cause a little bit of question so people will be curious and ask, and at the same time to give you as students the tools you need to actually be able to answer extremely well.
Thank you. I can't emphasize how important that point is, because one of the most common queries I get as an outreach person is, I'm pretty sure that I want to do computer science. Why are you putting me through this foundation year and making me confused? So I hope to all the students, parents, and educators that answers your questions. We have about 2 minutes to go, and I've got 2 broad set of queries. One is related to admissions and scholarships. I can answer that towards the end. But before that, both Dhiraj and Richard, if you could talk a little bit more about hands-on learning at Plaksha. Maybe if you have some details on how many internships or projects students would do at Plaksha, and how would experiential learning actually take place?
Okay, let me take this question, and perhaps Richard could make some inputs. So Plaksha, in fact, we want to create new identity of engineering education by completely changing the way things are taught. During some of my slides, I gave some specific examples. In fact, conventional engineering education in India is a lot about concepts. So you are taught concept, you are asked for mental problems, and then practice, you write exams, go ahead. Of course, we do experiments, but these experiments are, they don't go towards solving any specific problem. For example, of engineering, from University of Lucknow, and there we spent hundreds of hours in the lab, but these things did not really converge towards solving any specific problem. During my doctoral work at Cambridge University, whatever I did, in fact, I was actually solving some specific concrete problems. So that's our objective. In fact, from day one, in fact, we want to teach the students some basic concepts, and then we want to show them or let them immersed in some engineering context so that they're able to play with the tools. But our labs will be very different from conventional labs in the sense that we're able to fabricate things, we'll be able to make devices from scratch, integrate them, will let the students write codes so that they're able to control machines and so on. In that context, we will get help from our collaborators in the USA and other places. And in fact, as Richard has been pioneering a very innovative program in Purdue, which is one of the best in the world. So we're very much looking forward to people like Richard and others to create this unique experience of engineering education.
Let me just
Richard
add
may have something more to say on it.
Yeah, let me just add that the experience I think with that Plaksha is trying to explore, right, in this offering internships and connecting with international organizations, I think is very similar to a startup university in the United States called Olin College. And Olin had in many ways a similar view, is how to really create a new approach to engineering education in the United States. And those students have been, it happens to be located in Boston and not too far from MIT. And so it is, and those students are highly prized at places like MIT, at places like Purdue, at places really all over the world, because they too have this very interdisciplinary and holistic approach to not just the education, but these elements that you're asking about, what about outreach? What about internship possibilities? That's all part of being a global engineer.
Okay, thank you. We are already 3 minutes past 8, so I'll just take a minute to run everyone through our admissions and financial aid process, and then we'll have closing comments from Richard and Dhiraj. So Plaksha's admissions process is quite holistic. We don't just look at your cutoffs, and after this webinar, you would have realized why, because we are interested in more than your scores. We want to look at your curiosity, your potential to learn, what your story is, any extracurricular activities that you've done, etc. Entrance exam scores are not mandatory, but if you have taken SAT, JEE, etc., we do encourage you to submit those scores. If you are currently a grade 12 student and of course are awaiting your board scores, you can still go ahead and apply and just mention your predicted grades. All shortlisted students are called for a virtual interaction where you are put through a short design challenge where you're expected to solve a case study and you're expected to go through an interview. As I mentioned, our admissions are already open. The next deadline to apply is 21st of March. Just to clarify each round, what it basically means is that you have 4 windows in which you can apply. The sooner you apply, the sooner you get your decision, but it does not affect your chances of getting admitted in any way. Finally, I had some questions on, I'm very interested in Plaksha, I'm very interested in these majors, but maybe I may not be able to afford your kind of education. Well, I must assure you, 150%, you don't have to worry about that at all. Plaksha has very, very generous financial aid and scholarships. If you do get admitted to Plaksha or get shortlisted, we give you an option to apply for financial assistance, in which we ask for your family's ITR, etc., etc. And based on that, you can get anywhere between 0 to 100% financial aid. In the first batch itself, we expect almost 15 to 20% of our students to be studying on full scholarship. That is, most of them won't be paying any tuition or hostel fee. Another 50 to 60% would only be paying part of the fees, and then the rest paying the full fees. And apart from that, one thing we are really passionate about is to get more women in tech. At present, almost 25 to 30% of our applicants are women, and we do want to increase that ratio further. If you have more admissions related queries, I know most of you do because I haven't been able to answer all questions. I'll leave our contact details in the chat box in the end, and you can just contact us. With that, Dhiraj and Richard, any final comments from you?
If I can start, I just want to say I think this is both from my perspective as a professor and my experience as a student. You know, I think this is a really exciting opportunity, and that's why I've wanted to be part of it. And so I think it's something to really explore and consider the uniqueness of starting a new interdisciplinary curriculum like this.
So in fact, I just wanted to add that Plaksha in itself is a very unique experiment in undergraduate education. In fact, the programs which we are starting are very much unique, not only in India, but also in the world. In fact, even in the West, a lot of institutions have not dared to venture into this domain. For example, MIT's engineering is said to be the best in the world, but still, even now, they wouldn't dare to start a program in computer science and artificial intelligence at undergraduate level. Similarly, even now they're scared of starting a program in robotics and cyber-physical systems. So same is the case, same can be said about Stanford, even Cambridge, Oxford, and other universities. So we are starting a very unique experiment, which will offer some vital learning lessons, not only for us, but for others as well. Because in fact, it's very difficult and very challenging to put all these things together at a bachelor's level. For example, very simple problems. For example, turbulence is such a huge problem. So teaching such things to electrical engineers, mechanical engineers, so that they are able to develop skills in robotics is a huge challenge. But we are ready to take it up, and we are very much willing to invite you to be a part of this exciting, adventurous journey, which will really create a unique program as well as a new institution of higher learning. So thank you very much.
Thank you, Dhiraj and Richard, for ending on that very positive and exciting note. And thanks a lot to all those in the audience for staying till the end and joining us on a Friday evening. I hope all of you have a good day and a good evening.